Good morning, afternoon, and evening, everybody, wherever you are. Welcome to my second podcast. My name is Isam Hijazi, and I'm going to be your host. You are currently watching this live on YouTube and on LinkedIn for the very first time. Thank you, LinkedIn, for allowing me to use this new feature of yours. Today's topic will be about data, AI, and our climate. Understanding the climate dynamics of our planet is more important today than ever. It's not about fighting for future generations. It's about fighting for our present. António Guterres, the UN Secretary-General, said, "Climate change is quite simply an existential threat for most life on the planet, including and especially the life of humankind." That's you and me. Today, I'm really glad to be joined by Dr. Anya from London, who is a senior data scientist at Hitachi Vantara and also a fellow at the Nippon Foundation. That fellowship was awarded for Anya for her work in the Bermuda Institute of Ocean Science, where she studied the impact of the ocean surface layer on hurricanes' intensity. Her publications also on using IoT technology in climate research were featured in Nature and were one of the top-rated papers in global biogeochemical cycles journal. Anya was also shortlisted for the Women in IT Excellence Awards in the Rising Star nomination. All in all, a brilliant guest and expert to have in my podcast. Now, before I start this podcast, I would like to ask you to do something very simple. If you're watching this on YouTube, please do subscribe to my channel. Just click on that button right there. That way you can stay connected and updated with upcoming podcasts. If you are watching this on LinkedIn, please connect with me or follow me if we're not connected yet. And also, since this is a live podcast, anything that you write in the comments or chat will be visible to myself and my guest. So we might be able to incorporate that into our live discussion or answer your questions or simply say hello back. Now, without further ado, let's get started. Anya, good morning. It's so great to have you on my podcast.
Good morning, Isam.
How are you?
I'm very well, thank you. How are you?
I'm great, thank you. Thank you very much, Anya. Anya, I want to start this podcast with a simple question. What is all the fuss about this climate change?
Well, I think the quote from the UN Secretary that you said in the beginning actually captures it very well. Climate change is a real threat to our own existence, and the issue about climate change cannot be underestimated. And I think it's strange to me that so many people nowadays carry on with their lives without realizing the potential impact and potential threat that the climate change represents. Basically, over the last several decades, we were burning so much fossil fuels, and on the levels that our Earth, our planet, have never seen before. And we've been pumping so much carbon dioxide in the atmosphere that is one of the greenhouse gases that our planet started to become warmer.
And exactly, if I may ask you, what exactly has caused this, and when did it start? What is the timeline for this?
So basically, they attribute the excessive burning of fossil fuels to the start of the Industrial Revolution. And the observations of the carbon dioxide concentration, the continuous ones, they started back in 1950s. I think it was 1958, when David Keeling established observatory in Hawaii, where they started doing the continuous measurements of CO2 concentrations. And these measurements are also known as Keeling curve, and they show that basically the carbon dioxide concentration are increasing at a very, very high rate. So for instance, just to give you an example, back in 1950s, the concentrations of carbon dioxide was in the region of 280 particles per million. Right. Now we are over 400, and I think we're about 418. There are some seasonal variations as well. And also, to put it in the context, I don't know if you watched this movie called The Island President, or you know the story about the president of the Maldives. So basically, this is a small island country, and they don't burn so much fossil fuels themselves, but they can be affected by the climate change. right? So the sea level is rising and their land is getting eroded. So basically they're losing the country. And if we continue, like, burning fossil fuels and heating the planet, they can just disappear. And at one of the conferences in Denmark, the international conferences, he said that if we don't change the way we do things now, my country will disappear. And he was calling to keep the carbon dioxide level below 380. So you see, like, it happened more than 10 years ago, and everyone took it seriously, but still we failed to keep it under 380. And so kind of like, we're putting some small countries, some island countries into the threat,
right.
But they're not contributing themselves, but the whole international politics can make it impossible for them.
Right. So this sounds really dangerous and almost terrible, Anya. Is this issue really fixable or reversible, or is it permanent?
I think, like, the main fight at the moment is trying not to make it worse, right? So compared to pre-industrial levels, our planet is about 1 degree hotter on average. And the next milestone that was established by the international community is trying not to heat the planet above 1.5 or even 2 degrees Celsius. And these thresholds are very critical for many ecosystems, for surviving of our biodiversity, is for the sea level rise and all the number of extreme events and different things like that, right? So I would say that there's so many things that we cannot reverse back. So for instance, if you lose some part of biodiversity, right, you cannot recreate it, or, like, the process is not very straightforward at all. If you shift some ecosystems, some food chains, can you shift them back or readjust rapidly? The answer is no. If sea level is rising and the land is getting eroded, probably you can restore something back, but I mean, you create climate refugees and you kind of affect negatively to the coastal communities, and this effect is permanent. Also, if you have the increased number of extreme events such as like hurricanes or wildfires, like we saw in Australia, we saw the Amazon forest is burning. Well, you lose the forest and you lose the ecosystem that lived in the forest. So it's all very threatening, and it shouldn't be taken lightly.
Absolutely, it's terrible things. What happened recently, especially in Australia and around the world as well. So you're saying it's not that much reversible, but we can stop it. We can actually stop this from becoming worse than it is now. Is that correct?
Yes, absolutely. So in recent IPCC reports, and there was some sort of milestones that we can achieve, right? So by 2030, we need to achieve the significant decrease of carbon dioxide emissions, and also by the mid-century, we need to achieve like net zero CO2 emissions.
Right.
And this should be done through the international cooperation, through innovation, and through awareness of our population about what is happening.
Of course. So climate science in general show us that the risk from further warming can only be stopped by achieving zero net greenhouse gas emissions. Is that technically possible, Anya?
So there is some hope that it can be possible, but it's not just by cutting emissions. We need to have some innovation to actually to uptake carbon dioxide from the atmosphere. So this is how you achieve net zero. And through some advancements in the energy sector and the estimated investment that is needed to achieve the sort of innovation required in the energy sector is estimated in $1 trillion, or like 2% of our world GDP.
Right. Okay, I want to go back a step back, Anya, here, and we talked about the existential risks basically, and obviously it will touch the economic aspect of it. How long do we have? I mean, if we don't act now, if we don't try to do something about this problem, How long do you think until it becomes really bad?
So I say it depends how you define really bad. Just to give you an example, so if the planet becomes 1.5 degree hotter, we are going to lose around 50-80% of coral reefs, right? Because of the coral bleaching due to ocean acidification and increased ocean temperature. If the temperature, if the planet becomes hotter by 2 degrees, we are losing 99% of coral reefs. So, and also there will be some implications on fisheries and the food supply. So at 2 degrees, we are going to lose about 3 million tons of fish that is currently getting caged. And basically any increase of the temperature increases the bad outcomes. And in terms of the extreme events, I heard about this very good analogy, right? So we cannot predict that some of the catastrophic event is going to happen in 2 years, right there in this point of time, right? But it's all about the increasing probability of these events. So let's say you have a pair of dice, and I tell you you need to throw 12, right?
Mm-hmm.
And you think, okay, well, the probability is quite low. But what happens if you start hitting the planet, that you draw one more dot on each of the dice? So the probability of you throwing 12 or more is getting higher and higher.
Right.
And so we might see that the hurricanes can become stronger, that we'll see more fires. And also, yes, so I think the scale that we are talking about is several decades, and we will see it in our lifetime if we don't take a proper action and take it seriously and cooperate to mitigate and find a way to adapt to the changes that are happening.
Right. So in the next few decades, meaning in the next maybe 20, 30 years, if we didn't do something, we will see the impact of that on us, right?
Yes, absolutely. So the thing is, probably something like the climate change. It's you don't see it on day-to-day basis, right?
Yeah.
You say well, I don't quite understand how it can be the issue if yesterday was almost the same as today.
Mm-hmm.
But the time scale of these changes are not very large. So it's within the decades, we will see substantial impacts on, as I said, biodiversity, on our well-being, and some significant changes happening on the planet.
Right. So let's move into something a bit more positive, and that is your own research, Anya. I know you've done a research or thesis on ocean nutrient pathways associated with the passage of storm. Can you tell us a little bit about that research, please?
Yes, absolutely. So during my 4 years at the University of Southampton, I was working with the IoT technology. So it was ocean robotic systems, or let's call them sea gliders. So basically, this is a device, the autonomous device that you can deploy in the region of the ocean, and it goes up and down the water column and takes measurements of key oceanographic parameters such as temperature, salinity, chlorophyll concentration, optical backscatter, and other things. So the beauty of this technology is the amount of data that we can collect, and that we can deploy it and collect the data from the regions of the ocean that previously have been out of reach.
Right.
So just to give you a perspective, ocean is big and ocean is very difficult to measure, right? Yeah. One of the ways that we can measure the oceans is using satellites. But the satellites only see the surface layer of the ocean.
Mm-hmm.
So I think if you consider the chlorophyll concentrations, that is a proxy for phytoplankton abundance. And just taking a bit of a step back here. So phytoplankton is a tiny plant living in the surface layer of the ocean. And they're the base of most marine food webs.
Mm-hmm.
And also, these tiny plants, they generate half of the oxygen that we have on the planet. So the same amount as in inland plants.
Right.
And yeah, basically, if you see the satellite image of our planet, you see like, this kind of green swirls in the ocean.
Yeah.
So these are phytoplankton.
Okay. Good to know.
And yes, and if you see like the microscopic images of these plants, they're very beautiful. There are many different types of phytoplankton with different functions. And another thing that the abundance of phytoplankton tends to be higher in higher latitudes. And you can see that if you go to like the tropical seas, the water is nice and blue because it's oligotrophic. But if you go to like, more higher latitudes, the water is kind of, greenish or brownish. And this is due to phytoplankton growth. So the phytoplankton is very, very important if we consider kind of the carbon sequestration from the atmosphere.
Right.
There are two pathways that ocean can take carbon dioxide from the atmosphere. It's a solubility pump, so like, basically the carbon dioxide gets dissolved in the ocean, and it's also biological carbon pump. So phytoplankton uses light and carbon dioxide to drive photosynthetic reactions, and then phytoplankton can be eaten by zooplankton or other trophic levels, high trophic levels, and this carbon can think in the form of like, dead phytoplankton or like other microscopic creatures in the ocean, and it can be stored in the deeper layers of the ocean for thousands of years. So if you grow more phytoplankton, you have high sequestration, and you have food for high trophic levels. The thing is, there is a high seasonality in terms of how abundant phytoplankton is. So, for instance, in the North Atlantic Ocean, we see the rapid increase of phytoplankton population around springtime. That is called the phytoplankton spring bloom. And basically when it happens, you see like the big forests of these microscopic plants. But the exact mechanisms that trigger these events are still debatable. And also it's important to understand them to see how this event will evolve in the future, right? Considering also projected changes due to climate changes. So going back to my research, I was looking at the phytoplankton seasonality over the year in the North Atlantic, so in the high latitude North Atlantic. And there were lots of measurements of this event from the satellite data. But the problem with the satellite data that we have the multi-years, so we have measurements starting from 1997, continuous records, but it's only the surface, and there are limited amount of measurements during winter months because there is not, it's kind of dark, and the satellite doesn't capture that much data.
Right.
So there is a gap. And also, satellites cannot measure phytoplankton dynamics during storms because you have a massive cloud on top of your area of interest, and the satellites need clear skies. So another way that you can measure is you can go on the research expedition and deploy your equipment, or take the samples of water, go to the laboratory, etc., etc. But this you cannot stay on the research expedition in one place for a year. Like, first of all, it's very expensive. Second of all, you probably go crazy being on a ship and doing the same thing over a year. And second of all, if you have storm, you cannot do any measurements because you will be told by the captain and the crew that it's not safe, and it's not safe at all. But what you can do with the robotic systems like sea gliders is you can go on an expedition, deploy these systems in the area of interest, and then you can leave them there. And you only come back in a few months to change them, because the battery is out or something like that. Or you can kind of pick them up and use them in another mission. And every time the glider comes to the surface, it's translates the data that it's collected.
Yeah.
And it provides basically continuous measurements over years
Right.
of one particular area.
Right.
And also, it's a vertically resolved measurements. So you're not just measuring the surface, you have the whole profile. And I was using the systems to investigate the phytoplankton spring bloom event and how it happened, and also understand how much nutrients storms can bring to the surface to trigger this kind of mini phytoplankton bloom and probably generating the additional sort of pathway for carbon dioxide removed from the atmosphere. So, and just to clarify, the nutrients is the phytoplankton needs nutrients to drive photosynthetic reactions as well. And phytoplankton only lives what we call in the photic layer. So this is the surface layer where is enough light. And as phytoplankton grows, the nutrients are getting depleted, and that can be the limiting factor for the further growth of phytoplankton. Therefore, you need sort of mixing and to reintroduce nutrients from the deeper layers of the ocean back to the surface.
Wow, that sounds way complicated for my knowledge and background. But if I may, summarize what you said, and you tell me if it is correct or not. So these microscopic marine plants or the phytoplankton play a key role in moving the carbon dioxide from the atmosphere into the deep ocean, as well as forming the base of the marine food web. Is that correct?
Yes. And it's also there are two important things in terms of phytoplankton dynamic. It's abundance and the seasonality of the events. So for instance, if the seasonality of spring bloom is important for fish larvae, and if there is sort of mismatch between the events, it can have impacts on the growth of the fish. So, and another thing that is happening with the climate change that, as I said, our ocean is becoming warmer, and as it becomes warmer, it becomes more stratified. Right, so you heat the surface layer of the ocean more, and you limit this mixing that can potentially limit the amount of nutrients in the surface layer of the ocean, and it can have effect on the total, the biomass of phytoplankton that can grow. And also another important thing.
I just want to interrupt you here a bit, Anya, and ask you. So, in other words, would you say that in connection with climate change, is climate change making this process worse for it? I mean, is it like a mathematical direct relationship, if I may say so? This gets worse, that gets worse, and vice versa?
Yes, so basically, in terms of the dynamics of phytoplankton, you need to consider different regions. So the regional dynamics can be slightly different, and maybe with getting the ocean warmer can increase the abundance of phytoplankton in some latitudes, because if you have more stratified, you have more light. If you in a very high latitudes, but the overall projections that globally the phytoplankton biomass is declining, and but in order to confirm it, we need to have maybe a bit more years of the time series data to have the statistically significant evidence and to properly distinguish the climate impact from the natural variability. So as I said, we started the satellite records of phytoplankton measurements globally from 1997, so it's less than 30 years of data.
Excellent, great. So we're gonna talk about these robotics and the the techniques that you use in your research a bit later on. But I want now to jump into something I'm more comfortable with, and that is data. I've read somewhere that data has a carbon footprint, so it isn't as green as I was thinking or people thinks. My question to you, Anya, is it something that we should pay attention to, or it is a flow effect compared to other things that do produce carbon?
So the thing is, if we consider data or information communication technology sector, it has substantial carbon footprint, and recently it's been kind of under certain scrutiny, because I think the global carbon dioxide emission from this information communication technology sector are comparable with aviation nowadays. And as you know, that the amount of data is increasing, our kind of addiction to digitalization is growing, and we have more gadgets, we use data more and more and more. And so basically we need more data centers and things like that, but we need to be mindful of the potential implications in terms of the emissions. On the other hand, that is something good, that some companies have, geological companies have very strong commitments to be sustainable, and data centers of companies like Microsoft or Google, they're running on the renewable energy, and they are strongly committed to be to net zero emissions, or to probably negative emissions in the future, right? And their commitment also kind of helpful for renewable energy sector due to investments and utilization of technology.
And would you say this problem of data carbon footprint became noticeable in the past 10, 20 years, or was it since the 80s, 70s, or maybe before that?
I don't think that in 80s we were using the data that much. So the other day, we were talking about with one of my colleagues. So let's say we have a project, a data science project, where we're using hundreds of terabytes of data, right? Yeah. At the moment, we have the technology to store it, to process it, to analyze, to kind of build models and get value from this data.
Right.
And we also have the speed of internet is sufficient, if the data is coming from the sensors, we can obtain it, store it, and process. So we were doing this exercise where we're trying to see what happened if we had this amount of data back in 80s. And so I think just the processing of this data would be longer than my lifetime, and not even talking about the speed of the internet connection or anything. And in terms of the storage, I think it will be the data center of the several buildings. So I think I would say it gets more noticeable recently, and I don't think it was an issue back in 80s, considering the maturity of the technology, and that we were living in the analog world, and we're living in digital now. So
right. So would you say, from technical perspective, this carbon footprints that's coming from data, it's because of the electricity used to generate to power these data centers and store the data, or is it coming from something else? What exactly is causing the carbon footprint that's coming from the data itself?
Yes, I think mainly it's energy demands associated with that, right? And I think the energy demand for the data centers globally accounts for 1%, right, and of the overall energy demand, and is projected to grow in the future. And also, but the thing is that in terms of the technology for storing the data and the innovation that's used in the data centers, it helps to kind of manage it, because our sort of data centers become more efficient. We're coming up with the new technologies to cool the data centers, and without having this air conditioning and other things. So with the right sort of continuous commitment to sustainability and innovation, I think we can get the tech industry under control and make sure that the data that now we have all the tools to collect it, to analyze. We have many trained data science professionals, that we use it in the right way to to mitigate effects of the climate change, and to improve efficiency of the processes, to understand the processes better. There is a variety of applications.
Right. So just for people to understand. So when we're talking about data and the carbon footprints, we're talking about large scale of data, not the data that people would have regularly from on their mobile devices or on their laptops. We're talking about data centers and billions and billions of records, basically, right?
Well, I think if the contribution of each person also has some sort of carbon footprint, and we need to keep a close look on that. But every time you download images or send images somewhere, they're stored somewhere in the data center, right? If you store data in the cloud, it's not in a real cloud in the sky, and there is some sort of a physical data center that facilitates everything, and the internet communications. So, and the cloud providers, as I said, for instance, Google, they have very strong commitments to sustainability, and however, I was reading a report of the Greenpeace, and they were calling out another cloud provider and saying that they need to do more, and the impact of the data centers is substantial, and they need to think about other things rather than just profits.
Right. So this brings me. Sorry to interrupt. This brings me, Anya, to the question is, what people and organization can do to help with the process. Obviously, one of the thing I can think of is to have people maybe move to cloud, and not any cloud, to green cloud providers such as Google, for instance. And I think Microsoft is following that path, and maybe AWS as well as the other cloud providers. So I think now it should be a choice. A criteria choice, let's put it that way, for organization when they want to go to cloud solution, to also make sure that they are going with a cloud provider who is green in a way, and working for sustainability and to avoid this problem that we're having. Is there anything else that these organization can do, or that's pretty much it when it comes to the data footprints?
So the thing is, there are different opinions on that, and the exact impact of our technology is still being investigated. So some people can tell you that you should consider how many emails you send, or streaming video only in a low resolution and things like that. So I think
So if I'm watching video in low resolution, I'm helping the environment. Is that correct?
Yes, I think 50% of internet traffic is coming from the video streaming.
Right.
And so basically, if we consider the carbon dioxide impact from the internet sector, but I mean we cannot just stop using our digital technology, right? It's a part of our lives. And it enables people to work, to study in the situation that we are now, or just to communicate with each other. So I guess what I think is the right thing is to keep a close look on our industry and the carbon footprint on it, and see what sort of recommendations can come up. And
yeah, okay. I mean, those are pretty much what organizations should be looking at. Now on the other hand, another question, since we are living in the IoT and the AI era, may I say that we are lucky somehow to have these technologies around us? I know they are somehow producing data, and the data has a carbon footprint, but let's talk about the positive sides of these technology. Are they actually helping us to tackle this issue of global warming as well as the climate change?
Yeah, absolutely. So last year there was a paper from leading computer scientists, and they were describing different ways that we can use sort of AI and machine learning technologies to tackle climate change issues. And they were doing the call for action for the data science community to join it and to investigate different ways that we can help with the issues. So it can be anything from like, transportation, urban planning, energy sector. So it's creation of the smart grids. It's predictive maintenance. So for instance, if you have a factory, right, and if you making sure that you collect the data like around the processes from the sensors so that you understand the process. So first of all, you can decrease overproduction. You can understand when your equipment is likely to break. So probably like, the broken equipment produce damaged products, and you have the inefficiencies, or you have like air conditioning and you want to understand how to run it efficiently. So having data and provides understanding of the processes, it provides visibility, and having tools like machine learning and AI provides you ways to find little and big things that you can do to optimize your process and to reduce the carbon footprint. So, like, for instance, in terms of the smart seasonal urban planning, we can understand the patterns of people, like, the behavioral patterns. So how we can make sure that we can reduce to use this information to reduce the carbon footprint from the transportation. Also, the data can help to introduce infrastructure for greener technologies. So, for instance, if we consider like electrical cars, if we introduce them into the city, we need to make sure that the infrastructure of the city prepared, and it can be achieved through like multiple companies, multiple parties sharing the data, bringing it together, using the most recent technologies in advanced analytics and machine learning sector to make it happen. So with a growing amount of data, AI and machine learning provides like a great tool to efficiently get right results that can help with tackling climate change issues.
Right. So if I interpret this correctly, so IoT can help in driving us to what's called smart cities, and smart cities basically have interconnected technologies like cars with traffic controls and so on and so forth, and that eventually would be able to help us in reducing the carbon footprint, generally speaking, because we are able to optimize the operations in general. Same thing if you're talking about manufacturing, we are able to tackle the issues before they happen, reduce probably the energy consumption, and so on and so forth. Is my understanding correct?
Yes. So it's also like supply chain. So for instance, about the problem with the food waste that in our society we have a huge food waste that
Right.
also negatively affects environment. So if you install the you can optimize the supply chains to make sure that you waste less food. You can install sensors to monitor when the products are about to go bad, so you utilize them first and avoid them throwing away. And there is such a big room for innovation and potential implementation of these techniques in the variety of sectors in our life. So this is a great call to action to the data science professionals and everyone interested in the data and data science field.
Right. So, Anya, we're assuming that people understand what IoT means, but let's assume not. Let's assume some people maybe heard of the term but doesn't understand what that means. Can you describe in few words what IoT is and how the technology itself work and can be used by basically every organization?
Yeah, so for instance, let's first start that IoT stands for the Internet of Things, right? So it's multiple devices, interconnected devices that produce data. So let's say a great example of IoT, if we look at the digital train, right? And it has many sensors, the modern digital train. And if we capture the data from these sensors, we can build our algorithms for, let's say, predicting the failures or the potential failures of the train. And we can analyze data in the near real time. So this type of things that coming up now more and more, and something that we can use to tackle
So,
different
so, so, in
problems.
other words, IoT, people can imagine them as smart devices, or not necessarily smart, but they are like devices. Small could be that are planted everywhere, on machines, could be on buildings, on cars, obviously as well. And these small devices, they capture data. It could be things like temperature, could be like pressure, could be anything, right? And the data then is captured and stored somewhere else. That's basically what IoT is. Would you assure that?
So yes, so basically, yes, as I was describing before, like the thing that I used in my research, that was an example of IoT technology, right? So like
Right.
there was a robotic system that had multiple sensors that were producing data on different parameters that was captured and analyzed. Yeah.
Right. So robotics, IoT, that gives us a new level of automation, if I may. So we're not only now capturing data, but we're acting upon the data that it has captured. And this brings me to my second question: what can we do with the data that we capture from those IoT devices? People are hearing the terms data science. You are a data scientist yourself. The artificial intelligence, machine learning. What exactly is the role of these things, AI, machine learning, and data science in general, when it comes to climate change? Let's focus on the climate issue first, and then maybe we can talk about more examples.
Yeah, so basically, I think there are many definitions of data science or the data science professional, but I think the short and simple explanation is making sense from the big amounts of data, right? So I remember probably 20, 30 years ago, the analyst would be working in Excel or making graphs on a relatively short amount of data. But as we become more digitalized, as we have more data sources and more data is coming through, you need the professionals that are able to work with this amount of data, implement right techniques to get insights from the data, and to build to move from the descriptive to predictive or prescriptive analytics. So so basically what data scientist professionals do is, first of all, they have a specific problem, right? It starts with a problem definition. It doesn't start with just getting any data somewhere and trying to find something useful. It's there is a specific process, and the first step is data understanding the business problem and figuring out and identifying the specific metrics that related to this problem, and after that we go into the stage of data understanding. So understanding the data that we have around this problem. So for instance, if we want to build a predictive maintenance problem, if we want to build a predictive maintenance solution, let's say I'm a data scientist at a specific factory, and I've got a task that we have a machine, and we have several failures in the past, and we want to make sure that we can predict the new failure, so we can intervene on time before the failure happens, so we don't have the downtime, we don't have production of damaged products and other things. So this would be the business problem that we are facing. And then we need to understand, okay, what type of data we have to tackle this problem. So there will be, the sensor data from this machine, like vibration, temperature, and there will be also, for instance, data on the maintenance. So when the last maintenance was done and the history of previous failures. So all this information can be used to build a predictive maintenance problem. And then we go to the next stage, that is a data preparation. So often data, the real world data, the raw data, it's not, let's say, clean. It has some sort of issues. It can be duplicates, it can be outliers, out of range values, and other issues. So we need to have tools to efficiently process the data. And then we go into having this clean data set. We can go to the more analytical stages, such as exploratory data analysis, doing some plots, seeing how it looks like, and then we go into the stage of model building where we try different machine learning techniques or AI techniques that are relevant to our business problem, see the metrics, how they perform, and then decide which model is the best and which we're going to use sort of like in the production. So what I mean by the production is when we get new data, we deploy the model, and the model generates predictions. So we can say, okay, the next failure is likely to occur in 5 days, or there is a probability of failure is increasing, and we can advise the maintenance team to intervene on time.
Right. So if I want to summarize this, we collect the data, we store it somewhere, we prepare the data, make sure it's ready to be used for analytical purposes, and then we are able to apply machine learning and AI techniques in order to help us to predict certain events that may happen in the future. Is that correct? Right summarizing?
Yeah, so like that's, I think it's quite correct. So the process that I described is called CRISP-DM, so it's cross-industry standard process for data mining.
Right.
And it's basically a simple framework, and many data science teams do use it. And the core step of it is it starts with the business problems. And when you develop the model, you also need to go back and see if the results of your model are relevant to the business problem. So for instance, let's say if my model is accurate enough that I can predict failures on time, or is actually that the data that we collected is not sufficient to build reliable model for this task. And then we need to go back and see, do we need to redefine the business problem, or do we need to collect additional data, et cetera, et cetera. So it's there is a bit of the iteration in this process, but the framework is widely used.
And this framework is pretty much can be also applied to tackle issues related to climate change. Is that correct? And if yes, do you know of examples beside your research that you've done yourself?
Yeah. So for instance, there is if we talk about tackling the climate change issues, as I said, we can do it in a variety of ways. So first of all, it can be specific climate research, or it can be sort of processes optimization and improvement, right? Let's say if I know that I have a supply chain and I have an estimated carbon footprint of supply chain within my organization, and then if I collect data, I can create different business cases, or how I can potentially improve efficiency of my supply chain, and it helps to tackle climate change. Or it could be precision farming, or smart buildings. There is, as I said, there are multiple applications.
Gotcha. Great. All right, Anya. So we are a bit tight on time, and we've got some questions in the chat that I would like to bring up. So let me move to that. First of all, let's have some shout out to some people that have been waiting. We've got Han Hej. She's been waiting. I hope the wait is over now. We've got Dan Keeley. He likes the music, okay. And then Kimber, rock and roll, excellent. And then Kimber again, saying you sounds amazing, of course. And yes. And then we've got Siddhar. He's asking, you think the worldwide lockdown cause of COVID-19 has brought down the pollution level across the globe? That's interesting question. What's your thoughts on that, Anya?
Yeah, it's an interesting question. So I was recently watching the lecture from the climate scientist in the University of East Anglia, and they were looking in the impact of the COVID-19 on and this current pandemic on our carbon dioxide concentration. So basically, what they saw that around April time, when the biggest CO2 emitters went into lockdown, is that United States, Western Europe, Russia, Japan, we saw that the carbon dioxide concentration dropped by 17 or 25%. I can't remember the exact number, but it went back to the level in 2006. So, but the thing is, we should not think about it as we had pandemic, now we sorted climate change because, like, we are not driving cars anymore. This drop was quite short-lived, and the overall contribution to the issue that we're facing at the moment is very, very, very minimum. And basically, we didn't solve climate change with pandemic.
I think with the pandemic, we knew that we are the problem that's causing this climate change. We just paused it. And now once life goes back to normal, it will just continue. And we need to tackle it in the right solution that you've mentioned to us through this podcast. All right. And we've got a question from Kimber. She's asking, can we talk about how critical biodiversity and these ecosystems are to human survival? I'm not sure I understand the questions, but if you do, Anya, please feel free to answer.
So the thing is, our planet is, is designed in a way that the living of one creature supports the life of another, right? So we're not separated. It's a very delicate balance between different animals and different organisms. So let's say also we rely on biodiversity as our food. So for instance, if you break ocean food chains, you have less fisheries, and then you have less food. And there are many other impacts so saving biodiversity needs to be our priority because our life depends on it as well.
All right, we've got a comment from Jamil Juma. He's saying, beautiful, Anya, very informative and insightful. We've got a comment from Maureen. He's saying, yes, mostly because of less airplane travel. I think he's answering Sid here's question. And
because we spend more time at home.
Right. Okay, and we've got a comment from Sarah. She's saying, great podcast, Isam and Anya, very insightful. Thank you, Sarah. And then we've got Kimber again saying, Anya totally gets me. You've got, I think you guys should connect after this podcast. All right, so this is pretty much all the comments that we had in this podcast. Anya, do you have any final words, final thoughts before we end this podcast?
I think my final words would be don't take the issues related to climate change lightly. And my comment to the data science community is take a look at the paper that I mentioned and take a look at this call for action and think how you can use your skills and your abilities to drive this innovation and to help us all to tackle this change. And also, let's be more cooperative. We all live on one planet, and sometimes we need to, leave political issues aside and fight for our survival.
Absolutely, I think it's social responsibility on every individual, regardless where you are, where you live, and the problem is now. It's not happening next year or in 10 years. So we need to start acting now, not postpone it or take things for granted because. Obviously, they're not. We've seen what happened this year, the past few years from disasters around the world, and it will just get worse if we don't tackle this now. Anya, I would like to say thank you very much for being part of this podcast today. It's been really great to have you on the show. So thank you very much.
Thank you.
All right, so thanks everybody for joining today's live podcast. I hope you did enjoy it and found it informative. One last request from my side. If you're watching this on YouTube, please click on the subscribe button right there and click on like and comment. Let's continue the conversation. Also share it with your connections and friends. And if you're watching this on LinkedIn, also please like this video, share it with your connections, comment. Let's continue this conversation and follow me or connect with me. And let's also talk about this and other issues. Next podcast will be in another 2 weeks. I'll be talking about data governance. It's going to be an interesting topic with interesting facts that we'll be covering. Until then, you take care and we'll see you then. Cheers.